Hello, I'm going to demonstrate how to find a confidence interval when the population standard deviation is unknown. And when you have an unknown population standard deviation, you use what's known as t-scores. And just keep in mind, you do not use z-scores in this example that we'll do. So my example that I written out. Suppose heights of students at Victoria College are normally distributed and have an unknown population mean. A random sample of 35 students finds the sample mean to be 63.6 inches and a standard deviation of 3.55 inches. All of that relates to the sample right there. Now what we want to do is find the confidence interval for the population mean with a 95% confidence level. So what we need to do, I'm going to write out everything that we know. So we have a random sample of 35. That's telling me that n is 35. Now, what is special in this example, because we have an unknown population standard deviation, we are using t-scores, and in order for that, we need to know what is called the degrees of freedom. And the degrees of freedom is defined as n minus 1, so we'll take 35 minus 1 gives you 34. We will be using this later on in our example, but it is always helpful to find the degrees of freedom at the beginning of the problem, just so you don't forget later on. Now, next, we continue reading and you found 63.6 inches. That's the sample mean. Well, the sample mean is denoted by x bar because it's a sample. The mu relates to the population. So this is our sample. And then in our next part, we have standard deviation 3.55 inches. Now this really is little s, 3.55. This is little s for the sample standard deviation because sigma, the population standard deviation, is unknown. Okay, it didn't mention anything about a population standard deviation. We only were given sample summary of statistics. And then our confidence level, we want a 95% confidence level. I will label that as 0.95. Now our calculator, our steps. We need to go to the stat button. After you go to the stat button, you will have an option called tests. So I'll hit the stat button, go over to tests, and what I need to do is go down past the tests and really to the interval options. You can see here we have all these different interval options. We are going to pick number 8, and that is t interval. And t interval is being used because we use t-scores when the population standard deviation is unknown. It's just a rule that we follow. Now data. Do we have any data put in list 1? No, we do not. Now, if we did have the list of 35 students and all their heights, we could put that in list 1 and calculate it that way. But we have the statistics, so x bar is being asked first. That's the sample mean, 63.6. S relates to the sample standard deviation, 3.55 is given. And then n is our sample size, n is 35. Do not put the degrees of freedom in there. It will calculate degrees of freedom automatically in the background when I hit calculate. So when I hit calculate, it thinks, and we have our interval. And our interval has been created, 62.381, 64.819. Now the units on this, everything is in inches, so 62.381 inches, 64.819 inches. And then you can also see back, it gives you the summary of x bar, s, and n, and you could always double check that to make sure you typed in everything in your calculator correctly. So that does it with technology. Now, what I do want to do is demonstrate by hand. And if we were to do this by hand, we will need the t-score table. Now, when you're doing the homework, the t-score table will come up for you. In your book, you have the t-score table, I believe in the very, very end of the book, or maybe it's in the beginning of the book, depends on what book you're looking at. And here we have the t-score table. So these go with t-scores, okay, or the t-table. There's different ways you could call it. But what I want to do is immediately highlight our degrees of freedom. 34. You want to go to 34. Be careful not to pick 35. 35 is the sample size. The degrees of freedom is 34. Now, what next we have to pick? We have to pick one of those three numbers. So let's think back. Our confidence level was marked at 0.95. So just like earlier on when you worked with z alpha over 2, t alpha over 2 is also similarly used. So alpha would be coming from the confidence level, and remember the confidence level is equal to 1 minus your alpha, or by rearranging that, alpha would be equal to 1 minus the confidence level. So if you subtract that, alpha equals 1 minus 0.95, you will get 0.05. So we need alpha over 2. Half of 0.05 is 0.025. Knowing that, we are looking at t 0.025. That tells me I need to be looking at this column, and I need to match. So what intersects there is a value. The t-score that we will be using is 2.032. So this is our t-score. It follows the same pattern that you did with z-scores. Okay. So we have our t-score. An alternate way to do this is to type it in your calculator. So if you go second vars and go to INVT, now not every calculator has this. If you have an 83 version or an older 84 version, you will not have this. And then if I put the area in, I'll put the area in as 0.025 that came from our alpha over 2. And the degrees of freedom is 34. When I hit paste and enter, you'll see that it calculates negative 2.032. Now, we know by symmetry of a normal curve that positive 2.032 would really be the t-score. You could use positive or negative. It doesn't matter. Because when you make the margin of error, you're adding and subtracting, which we'll do next. So I'm going to go over here. I'm going to use my t-score. And I'm using the t-score because in the margin of error formula, you need your t-score. And then you multiply that by s over the square root of n, which is very, very similar to the margin of error formula for z-scores. For z-scores, it was sigma over the square root of n multiplied by your z-score. So since we do not have sigma, we don't have the population standard deviation, we have to use little s, our sample standard deviation. So I will put 2.032 multiply by our sample standard deviation, which is 3.55, and then I'll divide by the square root of 35. So let's see what this equals to give us our margin of error. So I'll put 2.032 times 3.55 divided by the square root of 35. When I hit enter, I get 1.21932. I'll take that many decimals. That'll guarantee that our rounding will match the technology way. And then once we have our margin of error, we have to create the interval. And the interval comes from, you take your point estimate x bar, subtract the margin of error to get the lower bound, and then you take your point estimate x bar and add the margin of error to get the upper bound. So what we need to do is recall back to x bar. It was 63.6. We need to subtract 1.21932, and we will get something in our calculator. You'll get 62.381, and then what we also have to do is add. Now a neat trick in the calculator, you can hit second enter and it'll retype what you did, then use the arrow, and I can arrow over and change it to a plus. and then you'll have 64.819. Now let's see, does this interval 62.381 and 64.819, does this match what we found earlier with technology? Well, I'll zoom right back over. 62.831 and 64.819. It does match, so we are happy. So either way that you do it, by hand or with technology, will always work. What we do after we've created all of our confidence intervals, we want to make what's called a confidence statement. And this is my confidence statement. We say a statement about the true mean, about the population. You always want to make a statement about the population. So we are 95% confident that the true mean height of all students, right? I'm saying all students because that relates to the population at Victoria College is between 62.381 and 64.819 inches. Thank you for watching.